Beating Musk to Mars. Mars samples delivered 2 years earlier than USA. China's Mars specimen return mission attempts to gather samples from the red planet and return them to Earth in 2031, 2 years ahead of a NASA-ESA joint mission. Sun Zhu, the head designer of the Tianwen-1 Mars orbiter and rover mission, introduced a new mission profile for China's Mars sample return on June 20th. He laid out plans for a two-launch profile, lifting off in mid-2028 and conveying samples to Earth in July 2031. The complicated, multi-launch mission will have a relatively simple architecture than the joint NASA-ESA project, with a single Mars touchdown and no rovers sampling various locations. However, if viable, it will deliver the first gathered Martian samples to Earth, which is widely acknowledged as one of the major scientific objectives of space exploration. NASA announced plans in March to postpone the next phase of its Mars sample return campaign and divide a lander mission into two independent spacecraft to decrease the program's risk level. According to the revised timeline, the Earth return orbiter would launch in 2027 and the samples would return to the Earth in 2033. Tianwen-3, China's mission, will consist of two components, a lander and ascent vehicle, and an orbiter and return module. The combinations will take off individually on Long March 5 and Long March 3B rockets. Earlier reports on the mission suggested that a single future Long March 9 super heavy-lift rocket would be used. The mission will build on Tianwen-1's Mars entry, descent, and landing technologies and techniques, as well as the Chang'e-5 lunar sample return mission's success in regolith sampling. Sun introduced the mission profile at a Deep Space Exploration Technology Forum, which was also part of a seminar series commemorating Nanjing University's 120th anniversary. The mission to Mars would take place in September 2029. Surface sampling, drilling, and mobile intelligence sampling, possibly using a four-legged robot, will be among the sampling techniques used. According to the presentation, the ascent vehicle will have two stages and will use either solid or liquid propulsion to reach a speed of 4.5 km per second. The spacecraft will depart Mars orbit in late October 2030 after rendezvousing and docking with the waiting orbiter, returning to Earth in July 2031. Sun also stated that as part of the sample return mission preparations, the Tianwen-1 orbiter will conduct an aerobraking test in Mars orbit later this year. Some of the mission's major challenges include technological complexity and autonomy requirements. Another noteworthy aspect is that the landing will occur around the autumnal equinox in the northern hemisphere, where the mission will most likely land. Potential sandstorms and a lack of solar energy are also challenges. China's Mars sample return mission appears to have the support of relevant top space and government officials. The country's ambition to carry out the unprecedented mission has earlier been mentioned, and it is included in the China National Space Administration's development plans for 2021 to 2025. Completing key technological research on Mars sampling and return was mentioned as a goal for the same time period in a January government space white paper. Two missions will precede the sample return. Tianwen-1, the country's first independent interplanetary mission, launched in July 2020, sending an orbiter and rover to Mars. Tianwen-2 will be a near-Earth asteroid sampling mission that will also make a stop at a main belt comet. Current plans call for a 2025 launch.